quirks
and quarks.
Hey everyone, and welcome back to the channel. I'm Polly.
And I'm Ailey.
Buckle up, Space Cadets, because today we're taking a deep dive into the science behind the smash hit sci-fi shows The Three-Body Problem on Netflix and Three-Body on Amazon Prime Video.
These shows have captivated audiences with their wild concepts, but the real science behind them is just as fascinating, though not quite as explosive.
We know your time is valuable, so we're going to make sure it's well spent. We'll try to explore aspects and details you may not find on other science channels.
So let's separate the warp drive from the wormhole and unpack the actual scientific theory, the three-body problem.
What is the three-body problem actually?
Imagine this. You're a celestial choreographer tasked with creating a ballet for 3 stars or planets. Sounds simple, right? Wrong. Here's the twist. These celestial bodies are all gravitationally attracted to each other, which is crucially important as we will see in just a moment. Picture Earth orbiting the Sun, a beautiful, predictable waltz. That's a 2-body problem. But with 3 bodies, the gravitational interactions become a chaotic tango.
Think of it like this. A small nudge in one body's initial position or velocity can send the entire system into a tailspin, making long-term predictions incredibly complex. This is why it's a problem. Finding a simple mathematical formula to predict their movements is practically impossible.
While there are some mathematical solutions that exist for specific abstract 3-body problems in the idealized world of mathematics, these solutions often rely on unrealistic assumptions that don't hold true in our universe. For instance, some solutions might assume perfectly spherical bodies or frictionless motion, which aren't present in the messy reality of stars and planets. Additionally, these abstract solutions might involve complex mathematical functions that are difficult or impossible to compute for real-world scenarios.
You might be thinking, isn't it really the n-body problem then? Absolutely. The three-body problem is just a specific case of a more general problem, the n-body problem. Here, n can be any number of celestial bodies, from a double star system to a sprawling galaxy, though it only becomes a problem when n is a positive integer greater than 2.
The three-body problem is a good starting point because it's the simplest case with truly chaotic outcomes. However, even with powerful computers and sophisticated algorithms, simulating the n-body problem for a large number of objects gets incredibly complex. Scientists use numerical methods to tackle this challenge. They break down the system into smaller pieces, calculate the gravitational forces at each step, and then keep iterating. It's like creating a stop-motion animation of the celestial dance, one tiny movement at a time.
Then we have the predictability horizon. How long can we see ahead? Even in less chaotic systems, there's a limit to how far into the future we can predict celestial movements. This limit is called the predictability horizon, or temporal horizon.
It's like trying to predict the weather. We can make decent forecasts for a few days out, but the further ahead we look, the more uncertain things become. In the three-body problem, the chaotic nature of the system shrinks this predictability horizon significantly. Small errors in our initial measurements quickly snowball, making long-term predictions unreliable.
And here's another interesting aspect of predictability. It also depends on scale. Imagine a meteorologist predicting the movement of a massive cloud system. With powerful computers and weather models, they can make a decent guess about where it will be tomorrow. However, zoom in further, and things get dicey. Can we predict the exact trajectory of every single water droplet within that cloud? Absolutely not. The chaotic interactions at that smaller scale become impossible to model accurately.
Similarly, in the three-body problem, we might be able to predict the general orbital patterns of the 3 bodies if we consider them a single system orbiting around the center of the galaxy, for example. This would be akin to a 2-body problem. But zoom in on the 3 individual bodies and the chaotic dance of these celestial giants relative to each other becomes unpredictable.
Now, before we delve into the scientific liberties the various authors took in the books and TV shows, here's a heads up. We'll necessarily have to discuss some plot points. If you'd prefer to experience the story spoiler-free, You can skip ahead to the conclusions towards the end of this video.
Now that everyone's been warned, let's shift gears and talk about the books that inspired these shows. Cixin Liu's phenomenal Three-Body Problem trilogy. These novels are masterpieces of science fiction, but they take some liberties with scientific accuracy for dramatic effect.
For instance, the books depict the Trisolaran Sun system as a chaotic three-star system with wildly unpredictable orbital shifts. While such a system is certainly possible, it's extremely unlikely to be stable enough to support even the simplest forms of life, let alone for an advanced civilization to evolve.
As a side note, the Three-Body Problem's title is also a clever misdirection. While the story focuses on the chaotic interactions of three suns, the planet caught in their dance adds a crucial fourth body to the gravitational equation, making the system even more complex.
But probably the biggest criticism to both the books and the TV shows is that while the story features scientists experiencing fear and despair, some readers and viewers have pointed out that this might not reflect how real scientists would react. In reality, there would likely be a mix of emotions, a strong drive to understand the Trisolarans, and intense collaboration to find solutions. Certainly not the extreme reactions the story would have us believe.
But hey, this is science fiction. The story takes some liberties to explore the dramatic potential of first contact. What do you think? How would real scientists react in this situation? Let's discuss in the comments.
All right, time to get down to brass tacks and analyze the scientific portrayals in the two shows available for streaming right now. We'll start with the Amazon Prime Video adaptation, which generally received better reviews for its scientific grounding. Here the show depicts the Trisolaran Sun system as a chaotic system with three suns constantly on the brink of collision. This creates a harsh, unpredictable environment for the Trisolarans. However, as we discussed earlier, such a system is unlikely to be stable enough to support life as we know it. The gravitational forces could easily rip planets out of their orbits, or worse, trigger catastrophic, life-ending collisions.
Both of these events are depicted in the show, but it requires a thorough suspension of disbelief to accept that, on the one planet that's left, such an advanced civilization could have evolved. This version of Three-Body features extensive scientific dialogue. While some viewers may prefer a more fast-paced narrative, these details will be appreciated by those who enjoy a deeper exploration of the science behind the story.
Unfortunately, the Netflix adaptation strayed quite far from the original material and from scientific accuracy in favor of a more westernized, all-special effect but please don't think too much approach. For example, the wall facers are actually not present in the original Three-Body Problem books. They are a concept unique to the Netflix adaptation. In the show, wall facers are individuals unrealistically entrusted with the daunting task of formulating Earth's defense strategy against the Trisolaran threat. The world can't come together to solve actual problems like ecological catastrophes and climate change, but we're supposed to believe that every government on the planet would agree to put three random people in charge of the future of all humanity. Suspension of disbelief is a powerful tool, but it has its limits. All in all, while both adaptations are enjoyable, the Quirks and Corkscrew found themselves leaning more towards the Amazon Prime Video version.
Despite their scientific shortcomings, the Three-Body Problem books and shows all play a valuable role in sparking our curiosity about the universe. The real Three-Body Problem represents a fascinating challenge in celestial mechanics, and who knows? Maybe with the advent of quantum computing and better algorithms, we'll one day be able to predict the dance of these celestial bodies with a greater degree of accuracy.
But for now, let's enjoy the imaginative worlds of well-written science fiction and be inspired to dream up solutions to real-world problems and push the boundaries of human potential. Thanks for joining us on this journey through the Three-Body Problem. If you enjoyed this exploration of science and science fiction, hit that like button and subscribe to the channel for more content like this.
We'd love to hear your thoughts in the comments below. What are some other mind-blowing scientific concepts you'd like us to tackle? Leave a comment and let us know. Cheers!